students. Shweta here, your maths teacher. Let us start today's class. See this picture. You can observe so many types of numbers here: real number, rational number, integer, whole number, natural number, irrational number. These are the types of numbers. I hope you already studied natural number. What do you mean by natural number? Yes, counting numbers are called natural number. What do you mean by whole number? Yes, natural number including 0 is called as whole number. Let us start today's class chapter 2, that is whole number. See, the real number system contains these numbers. Real number is contains rational and irrational number. Inside that rational number, integers are there. Integer inside whole number is there. Whole number inside natural number is there. You can observe here these numbers are represented by using a circle. Means in a whole number. What do you mean by whole number? How you define natural number including 0? The collection of natural number including 0 is called as whole numbers. Means in the whole number, natural number is there. So like that only, if you see the integer, I will give brief introduction about the integer. See here, 0, 1, 2, 3, 4, you know that is a whole number. But if you see the 0 left side part, see -1, -2, -3. See, these are all the negative numbers. These are all called as negative numbers. Why it is called as negative numbers? These are all represented by using minus symbol. So -1, -2, -3. So these are all negative numbers. And 0 right side number, 1, 2, 3, 4. These are all positive number. If there is no any sign, then you have to understand there is a plus is there. So +1, +2, +3, you have to understand that. So here integer contains 0 in natural numbers and also negative numbers and also a positive number. In an integer, it includes negative numbers and positive numbers and also including 0. These are all integers, you call it as. See, rational numbers and irrational number you will study in your higher classes. Let us move on the chapter 2, whole number. See, here natural numbers start from 1, and 1 if you add 1 you will get 2, 2 if you add 1 you will get 3, 3 if you add 1 you will get 4, 4 if you add 1 you will get 5, like that forever, because counting never stops. So if you counting and going, you will get the next higher number. So like the next greater number it will be obtained if you counting and going. So that's why I am telling you, start from 1. Natural numbers start from 1, counting forever is known as natural numbers. See, 1 apple. 1 apple if you had another apple you will get 2 apples. 2 apples if you had another apple you will get 3 apples. So like that, if you are adding and going, there is you will get the next increasing, this next number. So that is the reason natural number counting start from 1, counting forever is known as natural numbers. Let us define natural number. Number which will be used for counting are called natural number. So this is a natural number represented by using a number line. You can observe in this picture. Now whole number. See, the natural number along with 0 from the collection of whole numbers. Natural number is defined as whole number is defined as natural number along with 0 from the collection of whole numbers. The whole numbers are simply the numbers 0, 1, 2, 3, 4, 5 and so on. Here you can observe in this picture, inside of whole number, natural number is there. So natural number, whole number is defined as 0 including natural number. So that is the reason inside of natural number, if whole number is there, in that natural number also it will be there. Here by seeing this figure you can conclude that all whole numbers are a natural number, but you cannot say all natural numbers is not a whole number, because natural number start from 1. In the whole number 0 also is there. So that is the reason all whole numbers are called natural numbers, but all natural numbers are not whole numbers. Example 0, 7, 212, 1023 are all the whole numbers. Number line. See, number line you have to take the whole numbers and you have to draw a number line. Let us see how to draw a number line. See here, you have to draw a number line like this. and you have to take a whole number for that. See, if you have to add in by using number line, you have to move left to right. See, left to right, if you move means the number will increases. Increases means adding. So addition, 8 if you add plus 1 you will get 9. 9 if you add plus 1 you will get 10. So like that. So if in a number line, if you move right to left, then number will become decreases. So here 6 minus 1, then you have decreases means you have to do subtraction. 6 minus 1 is 5, 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2. So subtraction if you want to do means you have to move right to left. Addition you have to do means you have to do left to right. Like this you have to do addition and subtraction using number line. Multiplication on number line. See, let us take one example. 5 jumps each. Jumps is 2 steps. 5 multiply with 2 equals 10. 5 2s are 10. So this number you have to represent using number line means first you have to draw a number line. Then see here, the question is 5 jumps you have to jump, and each jump you have to jump 2 2. Each jump is 2 2, you have to jump. For example, 0 to 2 and 2 to 4, 4 to 6, 6 to 8, 8 to 10. Each jump you have to jump in 2 2 here. So you know that multiplication means repeatedly added. So I see here 2 you have to add 5 times here. That is only 2 you have to add 5 times. 0, 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. The answer is 10. Multiplication means repeated addition. For this example, see here 2. 2 you have to add 5 times. 2 plus 2 plus 2 plus 2 plus 2 is 10. And see here this first picture I already explained. Addition means you have to adding one for that. Successor, by the name itself it indicates success. See, for example, the you are last year in grade 5. So grade 5 you are promoted and you will promoted to grade 6, right? So here one number will be increased, one grade will be increased. So like that only. Successor means a successor is a number that is one more than the given number. Any number you are they are given, successor you have to find means you have to add plus 1 for that number. So for example, one successor is 2, 2 successor is 3, 3 successor is 4, like that. Predecessor, a predecessor is a number that is one less than the given number. See here, demotion is the best example. Demotion means, for example, anyone is an higher position, they will decrease for one position from that higher position. That is only a demotion. A predecessor means you have to subtract here, subtract minus subtract one number here. Any number they are given, you have to subtract minus 1 for that number. So for example, 2 predecessor is 1, 3 predecessor is 2, like that. 1 predecessor is 0, like that, because 1 minus 1 is 0. See, let us move on exercise 2.1. Write the next 3 natural number after 10,999. See here, next 3 natural number. Natural number means you are counting the number, counting 1 for that number. 10,999, next 3 numbers, natural number means 11,000, 11,001 and 11,002. Write 3 whole number occurring just before 10,001. Just before means subtraction you have to do. See here, the 3 whole number occurring just before 10,001 are 10,000, 9,999 and 9,998. Which is the smallest whole number? 0 is the smallest whole number. Like that only. Which is the smallest natural number? Yes, 1 is the smallest natural number, because natural number starts from 1. Write the successor of the following. I already explained. Successor means you have to add 1 for that number. For example, here 24,40,701 successor is, you have to add 1 for that number. If you add, so 24,40,702 you will get. Like that only. Here, see here, 1,199 successor is plus 1 you have to do, 1,200. Predecessor means minus 1 you have to do here. See, the predecessors are here 2,08,090. Predecessor is minus 1 you have to do, 2,08,089 you will get. Here See this number 76 lakh 54,321 predecessor is minus 1 you have to do 76 lakh 54,320. In each of the following pairs of the numbers, state which whole number is on the left of the other number on the number line. Also write them with the appropriate sign between them. Means here two numbers they will give. Which number is left on the which number you have to write here. See 530 and 503. You can observe here. See 530 is greater than the 503. So 500 and hence 503 is on the left side of the 530 on the number line. Here this number you can see 98,30,415. Here 1,23,001. So by the periods only it will be increased. For example, see here it is a lakh period and the another one number second number is a crore period. So crore period always crore is greater than the lakh. So you can write since 98,30,415 is less than 1,23,001. So hence 98,30,415 is on left side of the 1,23,001 on the number line. Which of the following statement are true? Which are false? 0 is the smallest natural number. 0 is not a smallest natural number. 1 is the smallest natural number. So it is a false statement. 400 is a predecessor of 399. See 399 predecessor means minus 1 you have. It is a false statement. 0 is the smallest whole number. Yes, 0 is the smallest whole number. 600 is the successor of 599. Yes, it is a true statement. 599 plus 1 is 600. So it is a true. All natural numbers are whole numbers. No, all natural numbers are not whole numbers. All whole numbers are natural numbers. Yes. In a natural whole number, natural numbers also included. So all whole numbers are natural numbers. The predecessor of two-digit number is never a single-digit number. See, if you see predecessor of two-digit number, so it will be never a single-digit number. No, it will, sometimes it will be single-digit number also. For example, you can see 10. 10 is a two-digit number. 10 predecessor is 9. 9 is a single-digit number. So 10 minus 1 is 9. So the predecessor of a two-digit number is never a single-digit number, is a false statement. Remaining true or false, you have to do it yourself. Let us move on properties of whole number. See, there are 5 properties of whole number. The properties of whole number includes closure for addition and subtraction. Closure property you can say. Commutative property for addition and multiplication. Associative property of for addition and multiplication. Distributive property of multiplication over addition. Identity for addition and multiplication. These are the 5 properties of whole numbers. This is very most important. Let us see on one by one. Closure property. See, what do you mean by closure property? Two whole numbers are add, subtract or multiply. If you do add, subtract or multiply, it gives another whole number. If you had if you take two whole number, if you had that number, you will get that answer also whole number only. This is only the statement says. This is closure property of the whole number. Let us see one example. It means that the whole number are closed under addition. If you had the number also, the answer also it will be a whole number, then you can say it means the whole number are closed under addition. Let us take example. If you subtract, then you can say whole number are closed under subtraction. If you multiply, whole number are closed under multiplication, you can say. So like that. For example, 4 plus 5 equals 9. Here 4 is a whole number, 5 is a whole number. If you add, you will get 9. 9 also a whole number. So that is only closure property says. If you take any two whole numbers, if you add, subtract or multiply, if you get a whole number, the answer will be a whole number, then the whole closure property holds. See, 5 minus 2 equals 3. 5 and 2 are whole numbers. If you subtract the two numbers, you will get 3. 3 also a whole number. 5 multiplies 6. 5 6 are 30. 5 and 6 are whole number. 30 also whole number. 0 multiply with 15. 0, any number you multiply with 0, you will get 0 only. So 0 also whole number. So hence closure property says this. Let us move on commutative property. What commutative property says? Commutative property for addition. Let us see first addition. Commutative property for addition, the sum of two whole number is the same no matter in which order they are added. If you change the order, the sum remains same. If your order will be changed, the sum remains same, then it is say that commutative property of addition holds good. Let us see one example. 5 plus 4 equals 9. If you add 4 plus 5 also 9. Let us see one example by through activity. See here. See, I have taken 1, 2, 3, 4. 4 plus 2. See, 4 plus 2 is 6. 1, 2, 3, 4, 5, 6. So like that only if you change order, first if you had 2, that is 1, 2 plus 4. Next 1, 2, 3, 4. The answer remains 2 plus 4 also 6. 1, 2, 3, 4, 5, 6. See, order will be changed. First you add 4 plus 2. Next you add 2 plus 2. The answer will be same 6. So that is only commutative property of addition says. Therefore 5 plus 4 equals 4 plus 5. This is only 5 plus 4 equals 9. 4 plus 5 equals 9. So you can say 5 plus 4 equals 4 plus 5. This shows that we can add whole numbers in any order. Multiplication. If you see multiplication, 5 multiply 4, 5 fours are 20, and 4 multiply with 5, you will get 20 only. Therefore 5 multiply with 4 equals 4 multiply with 5 equals 20 only. So this shows that we can multiply whole number in any order. So commutative property for multiplication says that the product of two whole number is same no matter in which order they are multiplied. If you multiply with any order, if you change the order also, the product remains same. So then commutative property will holds good. Let us see one activity. See here. See here. How many rows are there? 1. See rows. How many rows are there? 1, 2, 3, 4. There are 4 rows and 3 columns. 1, 2, 3. So 4 multiply with 3 equals 12. 4 3 is a 12. For example, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 multiply with 3 equals 12. So if you change order, I changed, I pasted like this. See, if you see how many rows are there? 1, 2, 3. 3 rows. How many columns? 1, 2, 3, 4. 4 columns. So 3 multiply with 4 equals 12 only. If you see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 3s are also 12. 3 4s are also 12. So multiplication, if you change the order, the product remains same. Associative property. Associative property of addition. See here, grouping you have to do. Grouping by using bracket you have to do. By taking a bracket, you have to group the number. For example, 1 plus 2 plus 3. You group first two numbers. That is 1 plus 2 you have to group. Then plus 3. First you have to add inside the bracket. See, BODMAS rule you have to apply. Bracket first you have to simplify. 1 plus 2 is 3. 3 plus 3 is 6. Then again 1 plus 2 plus 3. Next last two numbers you have to group. 2 plus 3. 1 you have to write like that only. 2 plus 3 is 5. 1 plus 5 is 6. See, if you do grouping also, if you add then also you will get the same number only. So that is only associative property says. See, first two numbers first you used bracket. If you simplify that, you will get the same answer. Then last two numbers if you use bracket, if you simplify, then also you will get the same answer. So 1 plus 2 plus 3 equals 1 plus 2 plus 3. This shows that results are same even if we change the grouping of numbers. Grouping of numbers change also, the result will be same. The answer will be same. So while adding whole numbers, we can group them in any order. Any order you can group and you can add the numbers. This is called as associative property of addition. Now multiplication. See, 2 multiply with 3. Here also, instead of adding, you have to multiply here. Grouping you have to do. 2 multiply with 3, multiply with 4. That is 6 multiply with, that is 2 3s are 6. Multiply with 4 is 6 4s are 24. So 2 multiply with 3 4s are, see 3 last two numbers you have to bracket. You have to use bracket. 2 3 4s are 12. 2 12s are 24. Therefore, 2 multiply with 3 multiply with 4 equals 2 multiply with 3 multiply with 4. So this shows that results are same even if we change the grouping of number. So while multiplying whole numbers, we can group them in any order. This is called associative property of multiplication. Distributive property. Distributive of multiplication over addition. 15. See, if you take 15, 8 plus 2. 15 into 8 plus 2 you can write. So this you have to distribute. Distribute means by the name itself it indicates you are distributing the numbers. See, 8 plus 2. 8 plus 2 is 10. 15 into 10 can be distributed as 8 plus 2. So 15 into 10 is 150. So like that only 290 multiply with 105. So to make this multiplication easy, we breaking or splitting or distributing the numbers here. 105 is distributing as, is splitting as, is breaking as 100 plus 5. 105 can be written as 100 plus 5. And then we will use distributive property. 290 105 can be written as 100 plus 5. So 290 multiply with 100 plus, so inside of bracket you have to multiply that number 290. 290 into 100 plus symbol is there in the middle. So then again 290 into 5. So that is 29,000 plus 1,450, 30,450. Let us see one activity. Distributive property. See here. Here, how many rows are there? 1, 2, 3, 4, 5 rows. How many columns are there? 1, 2, 3, 4 columns. So 5 4s are 20. See, 20 blocks are there. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 blocks. So like that only, see, I cutted this part and I have pasted another one grid. I make like this and I cutted this part, and this part I cutted, and one part I paste like here and plus symbol I used, and another part I paste here. So you can observe now how many rows are there in this first part. 1 2 3 4. There are 4 rows and 2 columns. So 4 2s are 8 plus, see here how many rows are there. 1 2 3 4. 4 rows, 3 columns. 1 2 3. 4 3s are 12. See, 8 plus 12 is also 20. So like this you have to distribute. I am splitting here and splitting, and I am adding here. See here, 4 2s are 8 plus 4 3s are 12. 8 plus 12 is 20. 5 4s are also 20. So this is only distributive property says. Identity law means 0 is called as an identity for addition whole numbers, or 0 is called as additive identity. What is the identity for addition means, you have to say 0 is the identity for addition. So it is called as additive identity because 0 plays a special role in addition. For example, 7 plus 0 is 7 only, 5 plus 0 is 5 only. So 0 plays a special role in multiplication also. Any number when multiplied by 0, you will get 0 only. 450 multiply with 0, you will get 0. So that is the reason 0 is the additive identity of that is additive identity, or identity law for which is the identity for addition means you have to say 0. And multiplicative identity, which is the multiplicative identity, means the multiplicative identity property says that any time we multiply a number by 1, product is the original number only. For example, if you multiply 1, so 1 is called as 1 is the identity for multiplication of whole numbers, or multiplicative identity for multiplication of whole numbers. See, 9 multiply with 1, 9 only. 7 multiply with 1, 7 only. So that is the reason you have tell that 1 is the multiplicative identity. Now homework you have, you see, go through this and write the homework and send a pic to me. Thank you.